Good afternoon, friends. I'm going to go back to the thing I do where I sort of talk for a little bit and make sure that the streams are working on both of the platforms I'm using because I didn't do it last time and the YouTube video got like weirdly cut off and I'm not entirely sure why. All right, but I see Twitch is good and YouTube is good. And we're ready to start. Welcome. Today we're going to be doing something that I'm pretty excited about. If you watch my Wednesday live streams, you know that we've been reading this paper, Attention is All You Need, that was published year before last now at NeurIPS, that proposed a new type of neural network architecture for sequence transduction tasks. Basically, you have an input string and you want a specific output string depending on what the input string is. So things like, say, machine translation. And what we're going to be doing is using this general architecture to make English sound old-timey. And by that, I mean take in modern English, and so like you would say today, and then have an output that is early modern English, specifically from the time of the King James Bible, because that's what we're going to use. We're going to be using Bible text because it's a nice parallel thing. And the only thing that I did before the start of the stream, because I want to show you guys the whole process, is I did a search to see if anyone had already implemented this type of model on Kaggle, and a couple people actually have. So we have one here by SL, which was for the Quora Insincere Questions Classification Challenge, and is which is continuing, and implements it using Keras. Give that a little upvote, so we do have an option there. And then there's also this one by Shujung that is using presumably something other than just NumPy. Maybe not. Maybe this is from scratch. Oh, no. Okay. Also using Keras. So yeah, I don't know. We might look at both of these, might pick one of them. The first thing we're going to need to do is get our data set that we're going to be using. So the reason that I'm using early modern English to modern English is that is a very, I think it's fun to put in like normal text that an English user would say today and get sort of a Shakespearean-y version of it. This is also something that previously people have attempted to do with rule-based systems. So if you search for like, oh, is this also... I think this notebook might also be another one that's, yeah, so we also have a third Keras transformer option. So there have been quite a few already implemented on Kaggle, and we can use those, which is nice. And there's also, I found this one from Harvard NLP, which goes through and reads the paper and then turns it into code, that I think we talked about when we were reading the paper on Wednesdays. And it took us a couple weeks to get through the paper because I only spent an hour per live coding session, and it was a very dense paper. Oh, right. So there are, if you search for like Shakespeare translator, there are some like fun little online things, and they are based on, as far as I can tell, a rule-based system rather than a neural system. So if I wanted to say, so it looks like I think here will always be here, even multiple times, which is something that a neural system probably wouldn't do. It would probably give you different output. Or U is always going to be interesting. Okay, so, oh, I see. So it's alternating whether it pulls from a list of two things. What about if I just say me a lot? Me will always be the same. Will my always be mine? Yeah, so there's a sort of replacement strategy that they're using, and sometimes the replacements are drawn from a list of two, just cycling through the list, and sometimes they are always replaced by the same thing, and there's also this sort of font change, and this is a rule-based system. So we're going to be doing sort of the same thing, but not with Shakespeare, because modern language translations, quote unquote, of Shakespeare aren't generally in the public domain, is why we're not doing Shakespeare, but with biblical text. Ryan says, I like the new Kaggle UI. I didn't think the first one from Shujian is correct. I talked to him a little bit and it does questionably bad in the competition. So that is good to know. I'm just gonna pop out of that one then, and maybe not use that one. I think I'm going to use this one because it has the most comments, and if you've seen me code before, you know I like a good comment, which is, I don't know, maybe not the best way to pick a code sample, but that's what I'm going to use. Yeah, so we're going to do sort of this thing, but instead of using Shakespeare, we're going to use the King James Bible, which I think was contemporaneous with Shakespeare. King James Bible. No, because Shakespeare was during the reign of Elizabeth, right? So that was in 1611. And he was a little bit before that. So it's not going to quite be totally Shakespearean, but sort of similar area. And this is not, I want to say, Old English or Middle English, which to a modern English speaker are kind of unintelligible. And I just want to show you what that looks like, because sometimes people will talk about Shakespeare being Old English, and I was an English major, so that's the sort of thing that's like, that's not right. Old, Middle, Modern English. Let's see if we can get a comparison. Usually you'll have some version of the Lord's Prayer. Yeah, so this is Old English. You can see it sort of has the dramatic tradition of capitalizing things. What are they? Nouns. So 3 is Modern English, then she went to speak this early Modern English tongue. This is then she gone to speak in this Modern English tongue. It's very different sounding. Shed says, hello, Rachel. Hello, Shed. And let's see, so this would be Dan. I don't know what this letter is. I think that would be probably, okay, so if that's an S, Visa Ald Anglistungen Eoth Speken. So it's pretty different from English as it is spoken today. I am a shark spin on Twitch says, sounds like Welsh. My accent is not the best, so it's very possible that when I'm trying to read Middle English, it's like, you know, from the islands. Foreign sort of sounding. But like, I don't know, when that flores and all that, that is not modern English, and it has pretty substantial grammatical differences. We had a much more complex case system, especially in Old English. Sort of the difference, one of the main differences between Old English and, oh, it looks like Welsh. Yeah, I can see that. Old English and Middle English was that Old English had a very rich agreement system, much more like German. And then due to a process of creolization with Danish, quote unquote, listen, there were some Vikings involved, there was a little bit of conquering, and then there was later some more conquering, and that was sort of the next big shift in the language. And this is not super relevant, but the point is we are not going to Middle or Old English. That would be an actual translator. This is a much easier task. The reason that I'm doing an easier task is because we should be able to do it with a smaller model, which means it won't take as long to train, so we won't have to spend as much time just sitting here watching it train and telling knock-knock jokes. So I think actually what I'm going to do is I'm going to fork this, and then I'm going to attach different data to it. Actually, no, let's find the data first. I think I'm putting the cart before the horse a little bit. So the data that I'm looking for is going to be the Bible text. So the reason I'm using the Bible is because there are, obviously there's the King James version, there's some other versions that are contemporaneous with that. And then there are a lot of modern English versions of the Bible, so I'm pretty sure we'll be able to find, I would be shocked if someone, yeah, there we go. So we've got a couple of examples. We've got some from NLTK. If this is all of the King James Bible and also has the English translations, that would be helpful. The other reason why it's nice to use the Bible is... No, it looks like... How big is this? 31,000 rows. I don't know how many verses are in the Bible. If you guys know more about the Bible, you might be able to tell me if that's all of it. But it looks like it's just the King James version. Oh, here we go. Translations. This one looks like what we want. That's a single speaker, so that's a speech data set. That's not what we were looking for. We're looking for text. Bible version key. Yeah, here we go. So we've got several different translations. I don't know what the Darby is. I was going to use the King James because it's the one that I'm familiar with. Webster would have been well after. World English Bible, Young's Literal Translation. So I'm just sort of wondering which of these is the most modern sounding and which of these is the most old-timey sounding. So let's actually look up major Bible translations. Yeah, there we go. So we can sort of get an example. We can get an idea of when they're from. Bede. Okay, so see, these, we do have examples of the Bible in Old English, so if we were looking for parallel text, we could use that, but I'm only interested in modern English. There we go, modern English, complete Bibles, date, sort by. Wycliffe's Bible, that is not modern English, Middle English. Okay, so we start with Tyndale, Cloverdale, Matthews, Great. I don't think we have any of those in this example. No. Taverners, Geneva. Do we have Geneva? We do not. King James. Okay, so the King James is the oldest example that we have here from 1611. And then the most recent, I'm guessing, is going to be either the World English Bible or the Bible in Basic English. Darby is 1890, so that's not, you know, that's not too recent. Basic English. 20th century, which is the current century, I think, right? No, 21st is the current century. Sorry, it's been a long week. 1941 and 1949, and there was a revision in 1965. So if we could actually find a slightly younger version, that would be even better. So Basic English was 1940s. What about World English? 21st century. All right. I'm liking the sound of that a little bit better. Updated revision of the 1901 version. Ryan says World English was newer. Yeah, I think that's what we're going to go with. From 1997. That sounds relatively contemporaneous to me. I was alive when that one was done. So I think we're going to use the World English Bible as our input to represent the way that we would use English today. Oh, and Shed also says world. Thanks, guys. I appreciate the help. Unfortunately, because of the lag between when I say things and when they actually get shown, sometimes your very helpful comments are like a little bit after I figured it out, but I still very much appreciate them. So we're going to go from the World English Bible, so our current English usage, and then our output is going to be the King James version, so for our oldie-timey version, because I think that's going to be our oldest one. And is the data structure for these parallel? So the World English Bible. Oh no, it has footnotes. Okay, well, we're gonna have to do a little bit of cleaning then. Do they have a lot of footnotes? So I say they have footnotes because I notice up here, I think the King James Bible, if it's the same thing that we were looking at in the other data set, was just like, in the beginning, blah, blah, blah. And here we have a little description of what this means, which I'm assuming is supposed to be a footnote. This is perhaps taken from a LaTeX document or something like that. So that's not ideal. We're going to have to remove those. But we have here the ID, the B, the C, and the V. I don't know what those mean. Let's see if the King James has the same. ID, B, C, V, T. That looks the same to me. It is exactly parallel. Fantastic. So what we have here is a set of, not quite sentences, but like short little verses, I suppose they would be. Book, chapter, verse. Book, chapter, verse, Ryan says. That is helpful. Thank you. My family is Christian, but I am not, and this is a little bit out of my comfort zone, so I appreciate the help. Okay, so we have a little parallel text here, and it looks like we have, I think I'm zoomed in too far to see the size of these. No, we definitely, just in the other data set that we were looking at, saw this length of the thing. Anyway, it's, it's the whole Bible, which is a fair amount of parallel text. And the text itself should be very similar. Again, this should not be a hard translation task. Most of the words just aren't going to change. And some of them will, and those will be the ones that will make it sound old-timey, hopefully. We'll find out. This may be a quote-unquote translator where you put something in and you get the exact same thing out because that's the most likely output. But you know what? It will do that in a very fancy way, okay? And in theory, you'd be able to, repeat the same thing with different training data. All right, so we're gonna, what's this called? Bible Corpus, English Bible Translation Data Set for Text Mining and NLP. And let's give that an upvote because that has been helpful for us. And let it add that data. Bible. Bible Corpus. There we go. That was the one we were using. And I'm going to keep the Quora data set in for a little bit now, just so I can see the structure of it. And because I have added a data set, it's going to need to restart the virtual machine. So that's going to take just a second. And then we can get into it. And my plan is to just sort of read through it once to sort of understand what's going on. Because we did read the paper, but very slowly, A, and B, I want to make sure I know what the code is doing, All right, so first thing I'm going to do is I'm going to get rid of this entire cell because, so this is the default cell that happens when you start a new notebook, and I can see that the things that are imported in here are also imported down here, and we don't need to list the things in the directory, so goodbye. A little bit tidier. All right. Import some stuff from scikit-learn. I think this is like a little library that tells you about progress bars. Yeah, that's right. So it sort of shows you how things that are going. Oh, so Ryan says that's the questionable transformer one I was talking about. It gets 0.619, which is relatively poor for that competition. That's helpful. I thought it was the other one that you meant. Sorry, that was my bad. Well, we might get started with this and then go through and do it different. So there's a lot of custom functions in here and some custom objects as well. Well, let's try it. If it doesn't work, it doesn't work, and that's okay. And we will try something else that works better, hopefully, or something else that works worse until we find something else that does work better. And there was in the paper, if you guys were here, this really helpful figure about tuning that showed for them their results on twiddling different knobs, basically different parameters and their results. So we might use that as our guide. Ryan says might be correct. Maybe transformer just isn't optimal for this task. Might be better for seek to seek. Yeah, very possible. The big advantage of transformers, according to the people who design transformers, is that they are much faster to train. Which sounds good to me. Okay, so the first thing we need to do is correct this path because we've added another data set, so our path is actually going to be slightly different. So let's check what these are. So these are CSVs, and I'm going to look at I do want a code cell, thank you. I'm going to look at the head of the CSV just to look like what it is organized like. Ryan says, you're braver than me. The custom Keras looks like a bear. Yeah, but I don't want to write it myself. I'm too lazy. And hopefully it'll be, you know, relatively modular and we can, I don't know. I live in hope. I live in hope. What does that look like? Okay, so we have the text. Oh, right. I actually want to know what the training data looks like. All right, so we have. Oh. Interesting. This isn't sequence to sequence. This is text classification. Yeah. So this isn't sequence transduction. Well, I guess that makes sense. I knew that. I knew that the point of this competition was classification because it's in the title. Yeah, it isn't sequence to sequence. So we may have to do quite a bit of fluffing around with it. Oh, no, I don't want to do that. Let's see. Is yours? Nope, that's also the classification. Ugh. Let's see if anyone's actually done sequence to sequence. I think that will be easier. All right, so Shujin, so this is the one that we were just looking at and forked. Can someone please explain how Kaggle works? We've got this one, but that is unfortunately, I think that's the one I just looked at. I think it is also not sequence to sequence. The annotated transformer, line by line, not enough attention. Let's take a look at this. So it's from this year. It looks like a movie review sentiment analysis competition, kernels only. Do y'all remember what the, let's see. Sentiment's probably also classification. Oh, and Ryan has shared a little GitHub link. A GitHub link. Attention's all you need, Keras. A Keras plus TensorFlow implementation of the transformer. Attention's all you need. Ooh, this does look good. Let me really. I might not be able to use this. Yeah. So I'm hesitant to use this because I don't see a license. And since if I use this code and then I make it public, it'll be licensed under Apache 2.0. I don't want to license somebody else's code. And also I think you can't. I don't know. I don't know how licenses work, man. They're scary. But yeah, this might be helpful. All right, definitely something to look into. And then here's one from PyTorch, and PyTorch should work in kernels, so that might be something to work on as well. Oh, and this one has a license, MIT. Commercial use, modification, distribution, private use. But I think you need to include the license, yeah. Anything that you want to do. But you have to include this. So I can do it on Kaggle, I just can't make it public because then that would change the licensing. That's something we need to make easier. So this might also be an option. Let's see, so this is the training part. Torch. Actually, let's just see. I'm going to start a new kernel and do something that I will sometimes do if I'm working on a new project. I just want to make sure that all the imports can import. And Ryan says the S2S file is relatively simple. Could use that as a template. Yeah. Let's take a look at that while we get a new kernel up and running. So I just want to make sure that those can all import. And then the... Wait, is this sequence to sequence? Sorry, is this RNN? The encoder. Grew, range and layers, self-RNN. Oh, that's right, that's right. No, there wasn't an LSTM layer, was there? There was a feed-forward network. One sec, let me check the network architecture. I don't know that this is exactly the same as what the paper did. So in the network architecture, we had multi-headed attention, which is not recurrent. Or maybe it's the embeddings that are recurrent. Embeddings are offset by one position. Learned linear transformation and softmax function to convert decoder output to predicted net. We learn embeddings to convert the input tokens and output tokens of vectors to dimension D model. Are those recurrent? Like, definitely the thing that it says, there we go, I'll start a new kernel. The thing that it says that it is the thing that we want, but I don't think that there's anything recurrent in the actual thing that we want to do. Shaketh says the back button needs fixing. I think this was the first, when I was doing the kernel, that was the first thing that it was. So when I hit back again, it just refreshed it. Yeah, oh, what was I doing? I was making sure that all of these things actually import. Nope. No module named transformer. Is this something that they have done for the purpose of this? Like, is there a module transformer in... Yep, okay. So this is a package that they have made, or excuse me, a module that they have made. We might be able to actually... Let's see really quick if we can just install that in a kernel. And all we need is there we go, the username and then the repo name. This may or may not work. I don't know if they have the right files for this to build. Yeah. All right, yeah, there's no shell build script. All right. I still think it's worthwhile to try and find somebody else who has done it and then build on them. Classify the sentences. Okay, yeah, so this is also a classification problem, so that's not going to be helpful. So we'd found in an earlier example that did not look like it would actually work. All right, and this is also Train and predict. This might actually be more helpful. So here is their encoder model. So they have the embeddings, which they do, and then the positional encoding. So these are functions that they've written. And then I think dropout 01 was what they used in the paper. And then they used, okay, so these are the author's experiments to do global average polling and global max polling. And then they're concatenating the two, and they have added a just a feed forward network, and then dropout after that, and then they've done converted that to a probability using a sigmoid layer. All right, so this is just doing more pooling and smearing basically over the different outputs. All right, so the config, build, adding positional encoding. Oh, that's blah, blah, blah. So the positional encoding was the bit where each item was assigned a function sort of thing. Oh, Ryan's got another link for us. I think this might be our best bet so far. Oh, okay, so this is from K-Pot. Are you K-Pot? You are Bruce Die 03. All right. Okay, so this is what's constructing the positional encoding. Okay. And then here's the encoder. So we've got multi-headed attention, residual connection. So around that's, where's the figure? Around there. Ryan says, I think everything after the encoder is competition specific. Could probably pretty much reverse everything from there. All right, and this is from this one. NumPy, TensorFlow, regex, and LTK. Implement the idea. Differences with the original paper. Okay, so he's using or they're using, I don't know, she's using a different data set. Vocabulary with words, not subwords for simplicity. So I think that would work for us. Parameterized positional encoding. Yeah. This was something that we really got stuck on when we were reading the paper. There was like some weird sinusoidal formula that they had. So you have like the sine and then the cosine, and then as you add additional things, you sort of increase the frequency, and it's got like a little, you know, wiggles to show you that the wiggles that are closer to the other wiggles mean that the words are closer together. All right. Yeah. I think this might be our winner, maybe? Because it's got the... Oh, this is so awful. Sunil says, if possible, put all links in video description. Oh, that is a good idea. Unfortunately, I don't have the computer that has the YouTube admin account on it open right now, but yeah, I will try to do that in the future. That means nothing. Oh well, anyway, hopefully our output will look more sensical than that. Machine translation, man. Okay. Module preprocessing train. So is this where you're building the encoder? Graph. Decoder inputs, load the vocabulary, the encoder. Okay, so this is where we're doing the encoder. So we've got the embedding layer, which is this one. And they are using... self.x, vocab size equals the length of the vocabulary. Oh, it's just an embedding layer. It's just a function that makes an embedding layer. Woof. And then we've got the positional encoding, and oh, okay. So you have your choice of whether it's sinusoidal or just the sort of learned one. And then dropout. Blocks. I see. So the blocks are multi-headed attention and then a feed-forward network. So multi-headed attention, feed-forward network, and then they are stacked one after each other. And then in the decoder, we have the embedding, the positional encoding, dropout, multi-headed attention with input from the encoder as well, so that's right here, and then we should have a feed forward layer. Yep. And then the final linear projection is okay, so this is just what takes the inputs and the attention and everything in and tells you what words you should get out given your embedding. And then there's things to specify what's happening during training. Okay. Yeah, so this looks like a good start. Does it have a license? What's your license? It's Apache 2.0, thank gosh. Okay, yeah, this is the code I'm using. So let's start by seeing if all of this will load into Kaggle. And I don't care about the encoding. All right, so let's try you. Meh. Is that an error bar? Or is that because all right, no module named hyperparams. From modules import star. Okay, so we've got to so those are specified presumably in, I'm going to close a bunch of things so that I'm only looking at things that are actually useful for me. Okay, so these are probably going to be from elsewhere in Y'all, I had an idea. I had an idea that I think will make my life much easier. I'm gonna go off on a little bit of a tangent, and what I'm gonna do is I'm gonna upload this repo as a data set, and then use it from there so I can import. So let's do that. So it's a little bit hacky. It's maybe not using the site as intended, but I think it will make it much easier because I don't have to copy and paste stuff and I can just call the script files. So I think this is live, otherwise I'm going to be very disappointed and sad. Yes. So you can upload data sets from GitHub now, and I'm just going to add the transformer code, and because it's under Apache 2.0 and I am including the license, this is all legal, I think. So this goes and it gets everything in the repo and it puts it in a single what the thing this is called. So let's create this. And then I should be able to create a data set. Yes, I want to go to the data set. So then I should be able to create a kernel on this data set and just use all the code, just like you would if you were working locally. New kernel, notebook. All right. It's thanking. And because they are doing, well, let's look at This one. Okay, so this is one we're using. So I'm going to close all of these other things that are not the ones that we're using and stop making myself confused. Oh, I should also star this. Star. Just so I have it for my own personal reference later. Okay. So has all the building blocks contain functions regarding loading and batching data, creates vocabulary files for the source and the target, includes this. So there should be a script to run all of this, I think. Let's see, position encoding. So, so these are the, I do just want to view the raw. So this is the, embeddings for the German words as a tab separated file. So we're probably gonna have to wait. No, these are the positional embeddings for each word. Wait, I'm confused about what is in this file. I thought that it was the I'm confused about positional embeddings, because I thought the positional embeddings were for the position in the sentence and not for the words with relation to other words in the vocabulary. Oh, this must be for the one-hot encoding. Okay. And Ryan says, I think it's just train.py to run it. Results. All right, let's see if we can just run it. I think we're probably gonna need OS for that, and then is it the magic? Or does it need to be magic? Python can't open train.py, no file or directory. That makes sense. Kaggle, input, repository. Yep, all those things. And then I think it was just on the top layer, right? Yep, train.py. Okay. Now that I've given you the path to the correct file, will you run it? He did say that this took several hours to run. Okay. No such file or directory, preprocessed slash. Let's change directory to /input repository. Oh, I don't need to do the slash actually, because that's just where we are currently. Repository. Can I change directory to here, or is it change working directory? Okay, that's not it. Notebook, magic, change working directory. I've done this before in a notebook and I just do not remember what it is. Oh, it's just CD. Gender. Oh, is it the percentage magic and not the bang magic? Where am I? What files are? Gotcha. I was actually one directory down. Okay, so now I have moved to the directory where I want to be, and I'm actually going to do that right after importing OS. I think I actually might not need OS. I think this might just be in the regular magics. And Ryan and Shed have both told me that it is CD. Thank you. That is helpful. Although again, the lag has made it just slightly too late. I might see about seeing I can reduce latency so that your helpful suggestions are very helpful at the moment I need them. Okay, and now we're getting errors, which is exciting to me. All right, so we've got a error. No such file or directory, corpora/train.tags.de-en.de. Corpora/train.tags. Yeah, that's not in this file, huh? That's not in this. What would you call this? Okay. So the downside of the process that we are using here, unfortunately, is that we cannot edit the code that we have loaded in. So what I'm going to do instead is I'm going to copy and paste just the train file so I can fix it. Okay. I know this is just going to read in construct graph, file not found. All right, no such file or directory, corpora/train tags.de-en.de. Okay. File built-ins de_sense xy load train data self xy g equals graph train print train loaded. So there's a file missing. Ryan says, oh my gosh. Sorry, seaplane. I don't know if you guys could hear that, but it was very loud for me. You're still going to need the hyperparameters and other imports or not. I think the hyperparameters are specified in hyperparameters.py, and I think they're just hard-coded in. Yeah, so the problem is that these are not the right files. So we're gonna have to change these. So let's add that in a new cell above. Boop. On the source train, oh, we're gonna need to add new data, aren't we? We're gonna need to add our Bible data. I know what you're thinking. Rachel, you could be coding this from scratch all the way back up. Yeah, I don't want to. I want to use other people's codes. Shed says, bang ls to see the subdirectories. Yes, helpful. I think the problem is, though, that the directories that this is referring to, these corpora directories, aren't actually in the files provided in the repo, and it's looking for them and not finding them because they're not there. Let's see if actually it's possible that corpora it's possible that they're not included because the author doesn't have the rights to them. Oh, Sphinx. I did a bunch of stuff with Sphinx in grad school. I remember Sphinx. Do you see anything for corpora in here? Corpora logged pre-processed. Corpora simple shortcut. Okay. I don't know what that means. All right, so now that we have our Bible corpus loaded in, let's actually, instead of making it a file, let's read it in. And let's do that before we change the working directory. And we also need pandas to read in the data. Ryan says they probably just ditched it because it was too big to keep on Git. That's possible. Again, they also just might not have had the rights to distribute it. Which, especially a lot of the data consortium, LDC, a bunch of the LDC data sets are pretty limited in what rights you have if you are using them. Old Bible read CSV, it's in input, Bible, and then the old one was the King James Version, and then new Bible, read CSV, and then the new one, the new one was the input, Bible. World English Bible, I believe, was the youngest one that we found. So, no such working file or directory. Kaggle not working. In Kaggle not working. Where am I? All right, and what's in here? Okay. I'm pretty sure I am where I think I am. Oh, yeah, that'd do it. Yes, that is the problem. The problem is that I've added another data set, so it has changed the file path to the data set, and not the problem being that I was not in the Kaggle working directory. Awesome, so that worked. So we should be able to... Fingerjaw says, can you please go over the Celeb A dataset on Kaggle with the progressive growing of GANs approach next time? Probably not. Yeah, I don't really do a lot of computer vision. Maybe I'll work on doing more of that. But I also think that this particular project is going to take a couple weeks. But I appreciate the suggestions, and just because I'm not taking it does not mean that it is not a good suggestion. It just means that it sounds hard and I don't want to do it. All right, so we need to get just the Bible verses out. XML. Oh, interesting. It may be looking for a much different file format than what we are giving it. Ugh. Well, hopefully not. Train.tags.dutchenglish.dutch. I'm assuming that these files, which we don't have access to, so I'm literally just starting from zero here. I'm assuming that these files are going to be text files like .txt, where each sentence is on its own line, which is the general way of sharing text corpora in NLP. And I don't know if that's right or not. But I guess we'll find out, huh? So the first thing that I'm going to want to do is I'm going to want to extract the column with the text in it from each of these. So old-Bible text equals old Bible dot. Do you remember what the columns were called? Because I sure don't. Let's look at one of them. T. Very helpful. Not opaque at all. That was the new Bible.t. And let's just see if these work. It's not gonna work. It might work. It's not gonna work. All right, we're gonna try something new that's absolutely not gonna work. No, the source is the new and the target is the old, because we want to put in normal English and get out old-timey English. All right, that didn't collapse. This one is definitely going to. This is not going to work. Yeah, that didn't work. No such file or directory. So it needs to be... Oh, it needs to be in a file. So we need to write it to our working directory. Python, write column of data frame as text file. Write content of data frame into text file. That is what I'm looking for. np.text dot save text across unp attribute values. So format D. I don't know what the D stands for. Note for np.saveText, you'd have to pass a file handle that has been created with append mode. I think the text file doesn't open. Oh, sorry, not append, append. Ryan says the tags part is where it doesn't work. Did I put in the wrong thing? Yeah, no, yeah. I'm doing the tags. So the problem is I've created these objects. The objects won't work. It needs to be a path to a file. So I need to create these as a file. So I should have ehad. I should have, if I take a look at these, just like a list of things. And I want to save it out as a file. So np.saveText. Let's try with open old Bible text.txt read and write as file. Let's what was it, np dot, I don't think we've imported np either, so I think we're gonna have to do that, dot save txt, np dot save, yeah, we haven't imported np, import np, nope, import numpy as np. Oh yeah, I see what the problem is. The problem is that I had already changed the directory and now I was asking it to look in a different directory, which is not where it is. But let's, instead of using the relative path, give it the, there we go. So if I give it the one that's not relative, no such file directory. Repository, Kubyong, well, I think it read those in. So let's see, that worked. TXT, and let's save out old Bible text. Invalid syntax. I think it needs append though. Yeah, all right. Save txt append. Is it? Oh, okay, I see. So I said read plus and it actually needs to be append. And does it need to be in quotes? Series object has no attribute text. Yeah, these both need to be in quotes, as it turns out, because that's the name of a file. All right, read-only file system. All right. So we can only save to the /Kaggle/working directory, so let's do that instead. Save text missing one required positional argument, X. I don't know what that means, so that things. Ryan Tesler says, old Bible text needs to be in quotes. Thank you. Again, the lag is making for a little bit of a more exciting thing than it needs to be. What is the thing that it wants? I've left the safety of the Stack Overflow question I was on originally. df values. You can also just use np.saveText access the np attribute value. np.saveText, you have to pass a file handle that's been created with append mode. Okay. What was the error again? Save text missing one required positional argument X. You have to write to the file. Oh, I see. Writing to the file, the object. Oh, a new error. That's good. Must be a real number, not string. mp.savex. Mismatch between array type and format specifier. So I think that's probably why they did that as values thing that they did here. Fnimit. Oh, I'm sure that means data frame, actually, now that I've thought about it for 2 seconds. Where are you at? There we go. It's a data frame. A number's required, not string. I see. Data values. So do I have to say that it is like so? Nope, that didn't work. We have a different exception. Mismatch between array dtype object and format specifier %d. All right, so this %d thing, can I say dtype object, I guess? All right, let's see what they said here. Maybe this means decimal? Let's look up the documentation. That might be more helpful. And then after that, I'm probably going to call it a day because it's a little bit after 5. All right, so file name, check. X, array-like, data to be saved in text format. And a single format, a sequence of formats, or a multi-format string, in which case the limiter is ignored. For complex X, the legal options of format are a single specifier, resulting in numbers formatted, a full string specifying every real and imaginary part, a list of specifiers, one per column. In this case, the real and imaginary part must have separate specifiers. These are all number words, which leads to me thinking that np.savetext will only work with arrays that have numbers in them, and will not work with data frames that have text in them. So that's not great. So what I'm going to do is I'm going to leave myself a little note. Save out just the text from the data frame. Start here next time. And I'm also going to add in a little note up here with the link. Doop, 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 doop. Based on code from GitHub here. Whoop. All right. So yeah, I'm just gonna leave myself some breadcrumbs. I'm a little sad we didn't get very far today, but also not super surprised. I knew that this one was gonna be a bit of an uphill battle, but plus side, I think that once it's working, this model specification is going to be great. We can just use that. It does rely a lot on these unique custom functions that the author wrote, which is great because it means we can use them. But the downside is that it is going to be kind of a lot of futzing, I'm assuming. So I'm going to have to, I imagine, do a lot of guessing and testing, and I'm gonna commit just so that I have a version that I can come back to and see what's happening. Ryan says, I don't think we're that far off. Just get to input correct and that should be good to go. Yeah, definitely. Unfortunately, because we don't have access to their corpora, we don't know what their input looks like. And I am literally just guessing. So if my guess is wrong, it's an informed guess, but if my guess is wrong, this might be a lot more hefty. But I think the actual machine learning part of the code looks good. So next Friday, yes, I will be here. The Friday after that, I will be out of town, so I might record something and have it played, scheduled. But next Friday, we'll hop back into this, and we will continue to futz around with getting the data into the thing and just get it all set up and working correctly. Yeah, so I think we succeeded in finding code under the right license that I feel good about using. We found a corpora. That's absolutely true. We found that Bible corpora, which is fantastic. It was already on Kaggle. I don't have to do anything. So props to the uploader of that data set. And we will get back into this next time. I have high hopes. I think we'll get through it. And I will talk to you guys then. Thanks for joining me today. I know it was maybe a little bit of a struggle bus, but you know, sometimes that's just how it be. And hopefully next week it'll be a little bit less struggle and a little bit more exciting success. And we'll find out then, I guess. Have a great weekend, you guys. Bye.